Hi, and welcome to Mike Likes Robots, where we share knowledge to accelerate robotics. And every day of this Advent of Code challenge, I've been able to start a new day's puzzle until today. Now, that's something that I expected because they do get harder over time, but I did spend a lot of yesterday's video having finished part 1 fairly easily, trying to get to a solution to part 2. So, as a reminder of what the puzzle is, let's take a quick look at the text. So we start from an initial arrangement of numbers, and then we repeatedly apply one of 3 rules to each number, and it extends out into a growing line of numbers. We then need to figure out how many numbers there are at the end of 25 iterations for part 1, and at the end of 75 iterations for part 2. Now, the point I got to yesterday was that I had tried to run it with 75 times just by upping the number of iterations, which took absolutely ages. I then tried to implement a cache where it cached the result of doing each number after how many iterations would it give a number. So that was poorly explained. So for a given number, after n iterations, what's the result? So every stage, it'd be able to look up what the result is. The idea being that if there are n iterations left, you can just look up the result from that cache. I tried that and it was no faster, maybe slower. So I've deleted that cache from my code. Let's go to the code now and take a look. So currently we have a function to apply the rule, which returns a number and possibly another number. We have a function that is able to modify the cache, but I don't think that that's the right way to do it. And we have a part A and part B function, which use a different number of iterations to get the result. So that's the current state of things. Now, while I wasn't recording, I wasn't trying too hard to think of what I could do. I did accidentally stumble across a post on Reddit. I didn't click on it, it came up as a preview, which I think gave quite a big hint as to the direction to take this. So I'm happy with that. I'm going to try and solve it myself. A hint is all right. For some puzzles in the future, and I've done this in the past, I've said, here's my code, can anyone give me a hint as to why it's not working? Just something to help push me on my way. That previously has been very helpful. Remember, there is a subreddit for Advent of Code, and the people in there are very helpful. Do post if you're having an issue, and someone will surely be glad to help. In my case, this particular instance, someone gave me a new test case to try against my solution, which exposed what the problem was with what I had written. So that was really helpful. I can't remember who that was, but thank you. And if I need to do that again, I will. I'll do it between recording sessions. But I think it's still possible to solve myself using the clue. So the clue, the hint I got is someone saying that for any number, after a certain number of iterations, it converges to the same number. So what I think this means for my solution is to look more closely in how the numbers grow over time and see if there is some convergence, a convergence or pattern. So I'm going to investigate that first. If that doesn't bear any fruit, I'll start looking at other solutions across the internet. And if that doesn't bear any fruit either, I will end up having to look for a solution on Advent of Code subreddit and then implementing it in Rust. I'd prefer not to have to do that, but I'd rather move on to a new puzzle rather than stay stuck on day 11 forever. So that was a long introduction. Let's start trying to find this pattern. This is going to be a much more investigative video rather than a coding video. So my first idea is, instead of doing a part A, I'm going to run a new set of stones. It will need to be mutable, actually. So I could construct it directly, but instead I'm going to do a from string, and I'm just going to pass it the number 0. Then I would like to print line the answer to part A. So this should take the number 0, part A. This should take the number 0 and apply 25 iterations. I'm also going to print out the length of the array at each stage. So first I'm going to take out this cache line because it doesn't actually help anymore. The cache was fairly easy to re-implement. I need to unwrap. There we go. The cache was fairly easy to put back in, so for now I'm actually going to remove the cache from here. From here, remove the collections hash map import and the from string. Actually, I think that is it. Oh yeah, now my stones after iteration does not need a mutable reference to self. It can just be self. Let's get rid of this code. And that should do it. Right. We don't need that. And we don't need that. We also don't need accumulator or the addition. I will keep a variable for the index so that I can print it out and see how it is evolving over time. So with that, I'll do a cargo run and let's see what we get. So it's immediately looking a lot like Fibonacci sequence to me. Oh no, that's +2, +4, +19. That is quite a difference. Tell you what, let's do it for part B and just leave it running for a while. And then look at the numbers that it's printing out as it goes. Okay, and this is why we couldn't even get to 75. This is how much it slowed down at iteration 37. It hasn't even got halfway on one number. That's why the cache wasn't giving us anything. Let's we might also want to look at the diff. So let's calculate the diff as well. So we're going to do let mute prev val is 0. This will be stones.length minus prev value. And then we want to update prev value equals stones.length. Let's run that and see how it does. Okay, so our pattern 1012037249. I'm not seeing a lot of sense in these numbers, honestly. But it's growing by huge amounts every iteration. Look at that. It's running up 1 million extra entries, over 2 million extra entries, 3.5 million extra entries. This was 12 million extra entries. It's no wonder that it's struggling so hard. And doing a recursive function call is not going to do any better. We'll probably just overflow the stack by doing that. That's why I wanted to do it the iterative solution, because there's always a danger of that with recursion. A recursive function call in this case would be you take each number and do a recursive call for that number. So you can imagine that if we're adding on 18 million per iteration, that's 18 million new recursive function calls, which will be incredibly difficult to handle on the stack. So far I haven't got any new information except to really confirm that what I was trying to do wasn't possible before. So I'm currently looking at this and seeing if the delta is some ratio of the input. I don't think it is. It's the numbers vary quite a lot. So this delta is around 1/3 of the size of the input. This one is around a third as well. This one's around a third. This one's around a third. That probably is around a third as well. Also around a third. I don't think we'll get an exact number by saying around a third, but maybe there is a ratio. So I think what I'm going to do is I'm going to take these numbers. I'm going to plot them using a Google Sheet. So I'm going to change this to just be only the value so that I can just copy and paste it into a column. Now we don't need this previous value, and we don't need this index either. Okay, so I'm going to run that, and while that's generating some numbers, I'm going to open up a Google Sheet. Okay, let's take our numbers. That should do it. Okay, paste in there. That's formatted correctly. And then each diff will be, we'll start with 0, and it will be this one minus the previous one. Now I should be able to auto-complete that down to here. And now I'm going to plot. I was looking at the ratio. I don't know if that will mean anything, but let's try it anyway. So it'll be this one divided by this one. So yeah, you can see it's round about a third-ish, roughly. Which is pretty interesting. I don't know if we can actually use that to make a solution, but it is curious that it settles towards a steady state. Let's plot this ratio. Yeah, you can see it jumps around and then it settles down to a steady state. So I would assume that over time it gets closer and closer to a flat amount. It's hard to say whether that helps us or not. Let's see if there's any. It would be good to get some more numbers, but we got far more than 25. Let's take our average. Of the last 10 or so values. 2.93. Now again, I'm not sure of anything here. I'm just I'm trying things out really. So I think we can do. It means there's some pattern in the rules that I'm not quite figuring out. So what I'm thinking is after a number of iterations, say 30, it calculates fully for that number of iterations, and then it just multiplies the number by 2.93 to the power of the remaining iterations. Which you can already see is huge, by the way. Like, let's say if it's 50 remaining iterations, that means that it would be a base of 2.93 to the power of 50 multiplied by whatever number is in here. Let's just format this as a number. So there we go. That's what we're expecting, and we're getting a lot of zeros on that. Which says to me that it's too round a number. Like, that's not the real number, that's an approximation. That's not good enough for an advent of code solution. So after a little investigation, I've made some headway into understanding the pattern, but not enough that I can come to an algorithm for solving it. It might be interesting to look at some of the one numbers as well, just to see how it works. And it might also be interesting to look at the values that come out. So let's carry on doing a little more investigation. I'm just going to rename this 0 lengths, because it's the input was 0 and it's all the lengths of the arrays that's coming out of it. So here's what I'm going to do is, instead of keeping it in its existing order, which is unnecessary, I'm going to sort it. Then, oh, that's actually quite interesting. What if we do end up having multiple entries for the same number and there is a pattern? That might be a solution. I'll have to think harder about that. That might be a good way to figure it out. Let's print out what's happening, and we'll see if we are getting multiple of the same number to begin with. Okay, so we're print lining, and we're not printing the length anymore. We're printing the array values. We're only doing part A, and we're starting with 0. Okay, that's a whole lot of the same number, it looks to me. That's a whole lot of the same number. Look at that. Okay, I think I may have an idea of how to solve this. Which doesn't just rely on the fact that we're getting these two numbers out a lot from the answer. Are there any more numbers that occur a lot? Yeah, this one occurs a lot as well. This one does. This one does. Yeah. It seems to be a series of numbers that occur over and over and over. So yeah, I think this will actually work. Let's give this a go. So I'm going to change this from a vector to a hash map. Let mute stones is a hash map new. I will insert the stone, initial stone, as the key and a value of 1. Now for you can get rid of that. For stone, in stones. For stone count in stones, we're going to apply the rule. Next stones will also be a hash map new. So I will keep using this copy strategy. I don't think it's as efficient as modifying the existing hash map. But I think with our new algorithm, it shouldn't matter that much. Okay, so stone count in stones. We apply the rule, fine. Then we next stones dot entry for left. If it doesn't exist, put a default, and that's fine. But I think I'm fine with using or default, but I'm going to be explicit and do or insert. Then I am going to plus equal the count. So this says if you take the stone 0 and you apply the rule, you get 1 and nothing. So our count will be 1 because that's what's in the array. Then we're going to or insert the key of 0. We'll get 1 from apply rule. We'll insert the value of 0 and then add count to it and save that. Now, what that means is that we should end up with a hash map with 1 and a count of 1. Then we apply the rule to 1. It becomes 2024 with a count of 1. And then as we keep applying, if we come across the same number, this step only executes if it doesn't already exist in the hash map. Otherwise, it will add on that many stones to that key. So if we do that, and we do it again here, whoops, instead of using the left entry, we use the right entry. Now we're not going to sort it. This is not okay because we need to dereference it. Now that's happier. Okay. I am actually going to get rid of some of these commented lines. I think they're fairly easy to get back if we want them. So, in fact, I committed this to GitHub yesterday. So I can just reset my repository to the way it was if I need anything back, or look at the diff within VS Code and copy chunks of text out. So yeah, it's fine to modify things if you're using some source control. It means you're not littering your code base with comments, which is nice. All right, so at this point we have a hash map. We're building it up over lots of iterations. For each unique stone value, we're only calculating the rule once. Actually, we're still calculating all the rules. Oh no, we're not, because the hash map. I wonder if it's plus equal count or it's multiply. I think it is plus. If we have 2024 100 times, and then the result of it is 20 and 24, we're going to have 100 20s and 100 24s. I think that is correct. So at that point, what is the stones after iterations? It is not stones.length. It is stones.values.sum. Okay, let's get rid of this print line. Let's cargo test to begin with, because we want to test it against our test code. That passes. Okay, that is, that means we haven't broken it, at least. Let's see how well it does on part B. That came back very nearly immediately, which gives me some faith that if we add a few extra numbers into the initial array, let's say we have 7 numbers in the initial array, it should take around 7 times as long. So that was practically instant. 7 times practically instant is still pretty damn good. So let's give this a try. Okay, we have a number. And that is the right answer. So I was not confident after yesterday that I'd be able to finish day 11 today, but was successful. So I would like to thank the Reddit post that proved it converged to a number. I didn't read your post. I will after this video, but even the title of your post gave me the hint I needed to actually solve this challenge for myself. So thank you. I'll link it in the description so you can read it for yourself if you're interested. With that, I'm going to park this challenge where it is and move on to day 12. So let's read through day 12. Okay, day 12 is called Garden Groups. And again, I'll read through this. There will be timestamps for when I actually start to solve the challenge. So if you want to skip ahead, feel free. Otherwise, I'll read through and you can listen in. Why not search for the chief historian near the gardener and his massive farm? There's plenty of food, so the historians grab something to eat while they search. You're about to settle near a complex arrangement of garden plots when some elves ask if you can lend a hand. They'd like to set up fences around each region of garden plots, but they can't figure out how much fence they need to order or how much it will cost. They hand you a map, your puzzle input, of the garden plots. Each garden plot grows only a single type of plant and is indicated by a single letter on your map. When multiple garden plots are growing the same type of plant and are touching horizontally or vertically, they form a region. For example, there's a row of A's, there's a square of B's, and there's a little zigzag of C's here. This 4x4 arrangement includes garden plots growing 5 different types of plants labeled A, B, C, D, and E, each grouped into their own region. In order to accurately calculate the cost of the fence around a single region, you need to know that region's area and perimeter. The area of a region is simply the number of garden plots the region contains. The above map's type, A, B, and C plants, are each in a region of area 4. Yeah. The type E plants are in an area of 3. The type D plants are in a region of area 1. Each garden plot is a square and so has 4 sides. The perimeter of a region is the number of sides of garden plots in the region that do not touch another garden plot in the same region. The type A and C plants are each in a region with perimeter 10. I can see that. Yeah, that's 5 and 5. The type B and E plants are each in a region with perimeter 8. Makes sense. The lone D plot forms its own region with perimeter 4. Right. Visually indicating the sides of the plots in each region that contribute to the perimeter using minus and pipe, the above map's regions' perimeters are measured as follows. Plants of the same type can appear in multiple separate regions, and regions can even appear within other regions. For example, oh, that makes it a lot more complicated. Okay, the above map contains 5 regions. One containing all of the O garden plots, which is this whole thing, and the other 4 containing a single X plot. The 4 regions each have area 1 and perimeter 4. For X regions, this is area 1, perimeter 4. Yeah. The region containing 21 type O plants is more complicated. In addition to its outer edge contributing a perimeter of 20, its boundary with each X region contributes an additional 4 to its perimeter for a total perimeter of 36. Due to modern business practices, the price of fence required for a region is found by multiplying that region's area by its perimeter. The total price of fencing all regions on a map is found by adding together the price of fence for every region on the map. In the first example, region A has price 4 times 10 is 40. That's an area 4, perimeter 10 makes 40 price. Region B has, I'm going to skip this, so the total price for the first example is 140. In the second example, the region with all of the O plants has price 21 times 36 is 756. And each of the 4 smaller X regions has price 1 times 4 is 4 for a total price of 772. Here's a larger example. I'm going to skip this and just take that it has a total price of 1,930. What is the total price of fencing all regions on your map? That is tricky. It was already tricky having the zigzag, let alone having regions within regions. I'm going to need to think about this for a bit before I start writing anything in case I write the wrong thing. I think we may want to build up a map of contiguous regions. So for each point we add on, we check whether it's able to touch another point of the same region, another point with the same plant type. If it is, then we add it into that block. That should hopefully give us these groups and also these groups. We'd also store them as points so that we know their index within the map. Then I need to calculate, the area is pretty simple. It's just the number of plants in a region. Cutting out plants from a region, that's going to be tricky as well. Okay, well, I have an initial idea of how to start this. I have a couple of examples to try. So let's kick off a new project. Copy in some of these examples and start to code a solution. I'll meet you there in a moment. Okay, so here I have my Hello World source code. I have 3 test files with the increasingly more complex test inputs. And I have some unit tests that just call a foo function and check the right results that I've copied in from the advent of code. And I've skipped over this because I don't think there's anything very interesting in there to watch. So I'm going to start by trying to parse the puzzle input, which I think is going to be a pretty important step. So let's define our struct. It's going to be a plant map. It's going to contain regions. Regions will be a hash map. It will contain a character, which is the code that we're going to use. The plant type, that is. And then it would contain a region or a vector of points to be all the plants in that region. But because you can have multiple regions, we're instead going to turn it into a vector of points. Then we close that hash map, and that's our first triple right angle bracket. Now, the compiler won't know what a point is, so as per usual, we need to copy from a previous day's. I should have learned the syntax by now, really, but I can always just copy. Util equals path ... util. Okay, I'll try and remember that for the future. So that should give us access to our point class. And now I should be able to use a point. Great. So now we know what a point is, and now we know what a hash map is. We can start implementing from string. From string for plant map. I don't think there's any issues that can come up with this, so I'm going to generate a kind of generic error type. This will be a plant map error with nothing in. That means our type error is going to be a plant map error. Then our from string function will take a puzzle and it will return an OK plant map with regions being a hash map new. That should be everything we need. I'm also going to do a bit more boilerplate because I don't want compile errors on my page. So I'm going to implement plant map. I'm going to have a function part A, which will take a reference to self, immutable, and return a usize. We're going to plug a 0 in there just to get it compiling. And then my foo will no longer be the case. Instead, I can do a let map is plant map from string puzzle dot unwrap and then let result becomes map.part A. I'm going to take this code and overwrite the foo lines with it. Excellent. And then unwrap is unhappy. Plant error needs to implement debug. Okay, so we're going to derive debug. Cargo test, we should get 3 test failures. Excellent. All right, let's start coding the parsing and then the solution. So my first step, I think, is to turn. It's going to be to turn the input into a hash map where the key is the plant type and the result is a vector of plants. A vector of points. Then I want to take that and group it by region, which should give me all per plant type the contiguous regions from within the total vector of plant types. So let's go about doing that. We're going to have a let mute map is hash map new. Hash map new. Okay. I'm then going to iterate over the puzzle lines. Although I'm going to use enumerates and indices so that I can track it. So for row index row in puzzle.lines, dot enumerate. And then I need to do for column index cell. Or this will be plant type, actually. Plant type in row.iter. No, row.cars.enumerate. There we go. Now I can take the map and I can insert, note, the entry for plant type dot or default should insert an empty vector if there's no plants of that type yet. Then I should be able to push. It can't because it doesn't know what this type is, and I will need to give it that type for now at least. So it's going to take a car, and it's going to have a vector of points in it. Now it should know that I can push to it. There it is. And it will be a point with the row index and the column index. Doesn't like that. Because I need to convert to I32 and I32. Okay, great. So far, so good. Now we actually want to form contiguous regions. So for that, I want to have regions, and I want to make it a probably a plant map group contiguous. And it will be, I'll call this for every single plant type. So I'm going to put it into a block. I'm going to let mute regions equals hashmap new. I'll return regions at the end. And then for each region, for each plant type, so that'll be our map dot iter dot map. We're going to, I can for each. So for each, and I will take the type, plant type, and locations, and I will return, I will regions.insert or extend. I think it might be extend by group contiguous, which will take the locations. I think extend needs more arguments than that. Actually, I think it will just be an insert with the plant type as the key. Okay, now if I do that, I need to take a tuple here. Okay, tuple. And then it doesn't know what group contiguous means, which is very fair. Okay, so group contiguous needs to go in this impl block because it's not part of the fromstr trait. It will not take a reference to self, but it will take locations, which will be a vector of points, and it will return a vector of points. So we are first going to return an empty vector just to get it compiling, and then this will take by value. We don't want to take by value. We want to take a reference to an iterator of points. And that's happier. Okay, and then why is that not allowed? So it thinks that it's okay. So I need to take plant map by reference maybe. Okay, yeah, that makes it compile. Right. So far we have read the map. We have got the puzzle types and all the points that that plant type appears within the map. Now we need to write the function that groups them into individual regions. Following that, for each region, we can work out its area and perimeter. And following that, I'll need some logic for figuring out if one region is within another and subtracting that perimeter off. That shouldn't be too difficult to do. I think I can see a way to do it, but this grouping contiguous regions is going to be a bit tricky. I need this to stop giving me error messages. Right. Let's think about this. I need an output, some kind of output. So let's just call it output vector. I'm going to return the output. Now, for every location within location, I'm going to check if there is an existing region that it joins to. Then I'm going to check every other region to see if it now is one contiguous region. That's going to be my algorithm, which is going to be a little bit painful to write, I think. But let's give it a go. Right, so for location in locations. Check if it matches an existing contiguous region. If matches, then region.push location, and to do check regions against other regions for join points. Otherwise, we are going to output.push a new vector containing just this location. Okay, great. So now I would like to check whether one point touches a region. So this will take a reference to a point, and points, and it will take a region, which will be a reference to a vector of points. So I think this will simply be, we take all the directions possible from the point, and if any of them exist within region, then it's touching. So it'll be region.contains. Actually, I can do for p in point dot. Let's import direction, which I need. Util direction. Oops, misspelled it. Okay, and then for p in direction double colon. Oop, I want direction double colon horiz and vert. Now I promised that I would come up with a better name than that, and I didn't, so that is going to be its name forevermore. If region.contains, not concat, contains, it will be actually direction D, and it'll be a point.add D.point. If it contains that, then we return true. Otherwise, it's false. That's our closure. Point.add. I always do this. I need to borrow them. There it goes. Okay, great. So if it matches the current output, so I should be able to do, although I'm not sure if I can only do this by borrowing. Well, let's get to that later. So I want to check if a point and point exists within regions and vec of point. regions.any, iter.any, region touches point region. If it matches, then I want to return that region. I think this will be a find. Then I can do an if let some region equals matches point output. Region.push location. Now I can't do this because struct with a similar name exists, cannot find value point. Oh, it's because it's a location, so I need to get the location. And the regions needs to be a borrow. Correct. Okay, then region.push location. I can dereference the borrow like that. Then, again, I dereference the borrow. Okay, region, it's behind. Okay, so I need to find mute maybe. It's a mute. Lifetime may not live long enough. I don't want to move it. I don't think I want to move it, no. So can I just directly call this function and it works better because it's not a return type? This would have to be a location. This gets commented out. This would be output.itamute.find. That does work better. Okay, any Rust gurus that would like to give me a helpful hand, please tell me how I should have fixed this closure so that I could get a mutable reference. Because the ownership meant that it couldn't live as long. It might have just been that I specified lifetimes. I think it would have been fine because the regions that I'm passing in certainly lives longer than the thing I'm pulling out of it. But I guess I needed to guarantee that to the compiler. Anyway, so we are pushing the location. Now we do need to check all regions against all other regions for join points. So here's what we're going to do for that. For I think it will be left index in it will be the output.iter for right index in, oh, I don't want that. Left index should be 0 to output.length. Although I could just take directly a reference to it. But no, I need right index to be left index to output.length. This will be -1 so that I don't hit the last. Let left region equals output left index. Let right region equals output right index. For p in right region, if touches P left region, then combine. Maybe I can iter this, and then that will give me, yep, and then this cannot move. I don't want it to move. I'd like it to be a reference. Okay, can't do that. It's a reference which is immediately dereferenced. Yeah, that's fair. Okay, so we are taking all of our current regions. We are taking the 0th region and checking it against all the others, and then the first and all the others, and the second and all the others. If any from the second region touch the first region, then we're going to combine them together. Now I'm trying to think if there's ever a case where a new point added could combine 3 regions. And I think it could. So I think I need to do I need to keep doing this until I run completely through. Oh, wow. Let mute no combines. Let mute found combine equals false. While found combine. This is getting very fiddly. Okay, so found combine is false. If touches found combine is true. And continue outer. Okay, so what that does is it will do one check until it finds 2 regions to combine. It will combine them together, which I still have to do. Then it will restart the entire combination check. And the only time that terminates is if it runs to the end of this outer for loop and doesn't find a combination. I'm almost certain this is going to fail, but let's carry on. Fine, so found combine is true. We do need to actually combine them. So for that, I need to how do I do that? Let mute left region combine left index is none. Let mute combine right index is none. If touches, then combine left index becomes sum left index. Combine right index. Oops, combine right index is sum right index. At this point, we don't need this. I can put this above the loop and check that combine left index dot is none. I don't actually even need to check both of them. But I do need to reset them at the start of the loop. Okay, so I can do that. Combine left index is none. Found combine we get rid of. And then we don't, that's not outer anymore. Instead, we break outer. Now, if we break outer, and we can check if this is sum, then we need to take our output, combine left index, dot unwrap, dot extend, output, combine right index, dot unwrap, unwarp, apparently, unwrap. It might not like that. Yeah, I thought as much. Okay, so let right region equals output dot remove. Combine right region, right index dot unwrap. And put it here. Right region. Okay, that should be my contiguous regions implementation done, which means the puzzle is completely parsed. Which means I still need to write the logic. But for now, I can derive debug on the plant map and take a look. At whether I've parsed this correctly. Let's do that. So I'm going to println with a debug format on map. I'm just going to comment these out for now. I know they'll fail. I just want to check one. Running one unit test, running forever. Good stuff. Okay, so there's an infinite loop there somewhere. Let's debug it and see where we get to. I'm going to assume that we get to here at the very least. Let's debug. Let mute regions is hashmap new. Need to insert by group contiguous. If I get to here, it would return. So it's definitely within this function that I'm having issues. So let's go into here and let's run to the breakpoint. Okay, we're setting up our touches closure. That's fine. Now we should find output.push. There it is. Okay, now we found a second point. It is touching the first point. So we want to push that. And then we're checking to see if anything needs updating. So we only have one. If this is sum, it's not. So that's the problem. It's not, and then this runs as long as it's nothing. Okay, so I can fix this by making this sum 0, which will immediately be reset at the start of this loop. So let's run it again. Test. And we actually do get a B plant, which has 1 0 1 1 2 0 2 1. C plant with apparently 4 points, which it does have actually. So that's 1 2 2 2 2 3 3 3. An A point, which is all of these, and a D point, which is a single E point. And that worked very well, actually. Combine right index is never read. It's read here. I guess it doesn't need to be specified outside of the loop. Is that why? Yes, that is why. Part A is still A. I can format. Okay, great. So we have our regions. I've just found that my time is up. I think I'm doing quite well, so I'd like to at least solve part A, unless it's taking too long, so I'm going to continue on. I'd like to run it against the other test puzzle, just to see whether it can do separate regions and combine that entire O region together. So the O region, oh, we need the print line. Okay, cargo test, and we get that X is 4 separate vectors of points. That's what we want. And the O is a giant series of points, but it looks like I can't see any square brackets in the middle of that. So yeah, it's joined all of those O's into one giant area. So that has worked exactly as we need. Okay, so that's really good. So let's start trying to solve part A. So my logic for this, the area is going to be pretty simple. It's just going to be, for each vector that I'm checking, I take the length of the vector. Done. The perimeter is going to be slightly more tricky. I'm not sure off the top of my head how I'm actually going to calculate that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the C's have a perimeter of 10, the B's have a perimeter of 8. Okay, I think I have a possible algorithm. I think what you do is, for each point in the vector, you assume it has 4 walls. You then remove 1 wall for every time it's touching across where that wall would be. So if I run this with the 4 A's, I assume it's 16 walls. I then realize that it's missing 3 walls. So that would be a perimeter of 13. That's immediately wrong because the perimeter is 10. So that doesn't work very well. But why not? I feel like that logically works. So if I have 4 walls, 1, 2, 3. It's because for each, I need to take away 6, not 3. I counted the wall once, but it's actually removing 2 walls. So for each point, I check if it's touching another point, and if it is, I remove 2 walls. That's how I do it. Let's try writing a function for that. Okay, so I want to have a function that is the perimeter of a vector of points. So it'll be a region, which will be a reference to an iterator of point. It will return a usize, and I could even define an area function, although realistically, it's just abstracting a call away to the length. So that's fine. Maybe it makes my code more readable. What I'm trying to do more understandable. Okay, so let mute initial perimeter. Actually, let mute rim is region.length times 4. Then for left index, for left index in 0 to region.length -1, I'm checking 1 point against all the other points, and then again, and then again, and then again. I keep thinking ahead when I should be typing. For left index to region.length, we're going to look up the left region is region left index. The right region, what am I talking about? A region, it's not a region, it's points. So it should just be left, left and right. And we can take references to the region so that we don't region right index. Now we need to check if those 2 points are touching. So can I do right.diff? I can. Left. If direction double colon horis and vert.contains right.diff left, then parim minus equals 2. Return parim. I need to reference that. No. Reference both of these. No. Oh, I need to turn a point into a direction. I kind of need to convert it. Let's let dis is direction horizon vert. I could even convert it to a hash map. So that there's a lookup that's much quicker. Let's do that. Let mute dis is a hash set new. Do I need to import that? Yes. For dir in direction double colon horizon vert dirs.inserts dir.point. Then return dirs, semicolon that. Then I don't need to do that. I just need to do if dirs. Don't need to reference that, and that should be it. Okay, so I should have enough code now, almost, that I can do test 1 and that I can do test 1. I don't think I can do test 2 yet because I need the enclosures logic. So let's try it out for test 1 and see if we can get test 1 to pass and test 2 to fail. Okay, so my part A will be that puzzle is include string. Actually, no, I've already parsed myself. That is not smart. So I'm going to take my regions, .iter, .map, where, what do I contain? What's in this hash map? It's a character. I actually need, I don't need the key at all. So I can take it and I can take this, the regions list for that plant type, and I can return the self dot I would do regions.iter.map. For a region, I can return the self.area. Would be plant map area of the region multiplied by plant map of the perimeter of the region. I can even combine those into a cost. So let's just call this function cost. Again, it's region and brackets point, returns a usize, return plant cost map or plant map area region multiplied by plant map perimeter region. And these are all just helper functions that make it a little bit easier to see what I'm trying to do. So once I've done that, I then need to sum it, and then I can sum the result. Why can't I sum this? Because it needs type annotations. Well, we know it's an iterator of a U size. So wouldn't it make sense to sum to a U size? I guess it can't. It can't automatically assume that. All right, let's try the cargo test. Fingers crossed that part 1 passes. Part 2 passes as well. That seems wrong. Part 2 has enclosed regions. It shouldn't pass. I checked that, and then I did a total perimeter. Did I accidentally solve it? I feel really unconfident about this. Okay, part 3 failed. And we're meant to get 1930, and we actually got 1466. I want to check that I've put the right answers in for these. 772, right. Makes me worry that I've calculated the perimeter wrong or something. I expected to have to tell whether a region was completely enclosed by another region, and if it was, to exclude that. Okay, let's take a look. So I would like to print out for each letter what it should be. So I'm instead going to iter, and I'm going to take the key. This should be a tuple. In fact, while I'm debugging, I am just going to copy this function. I'll update it if I find a fix. Let's take a key, and let's do this manually in a for loop. So for region in regions. Oh wait, I can actually just say let sum is, and then take this. Just like that. I can print line that the result for type this is this, and then give it the key and the sum. Then I don't need this, and I can return sum. This is unhappy because I'm still passing in values. I need to iter. We don't need this accumulator. Let's give that a go. Okay, let's have a look. So, result for R is 216. Correct. I is entirely wrong. Very, very wrong. Okay. S is 24 for both of us. E is very different. C is different. R is the same. I is very different. F is 180, which is different. Let's go through these in order. E, different. C, this has multiple C rows. A region of C plants. Okay, so I've summed them together, and it hasn't. let's try and account for that. I together will be 340, whereas I have 284. C plants will be 398, which I don't have. F, are there multiple F plants? No, but they're different. V, 260, that's the same, so I can get rid of those. So we have 3, 6, 3, 6 rows. Oh, M is the same, so I can get rid of that. Okay, so these are the plants that have, these are the plants that have different values from the correct solution versus mine. So let's pull out test3.txt and take a look at it. E is a very odd region. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 13 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Is that what it said? E plants 13 times 18, 234. So why did mine not get that? Show me all the information for my E plant. That's 0, 1, 2, 3, 4, 9, 5, 9, 6, 9, 7, 9, 8, 9, 9, 9. They're separate regions. They're separate regions in mine. Okay, so the contiguous is not working. I think my part A will work if only I can get the contiguous regions to work. So why did that not work? So my group contiguous logic has 3 separate regions, and it looks like it's checking column, column, column. Horizontal and vert contains up, right, down, and left. To point, let's check they're correct. I mean, we've used this code a bunch, so it should be fine. Down and left, yep. For the direction, if the region contains that, then true. So we should have at this point that when we add, say, this, so this doesn't have left or up, so it will combine, it will create a new region for it. So what happens then is that when we add this next E here, it should look over all the current regions and combine them together. So our combining logic is not working. So let's double check this. Let's put this back here. Right, so we have our set of regions. We check left and right. So for the E region, we should be saying okay, so we're looking at E. We've just gotten E and E, so we should have these 2 points in. Then we're adding this, which should combine these two into one. So when we add it, it should figure out to combine it to the left index. Then we're iterating over all the points in the second region and checking if they touch the first region. They should. I'm just going to run this and see if it says it ever combines. It doesn't. It doesn't ever combine regions when it finds that they're joined together. Okay, so my combining logic is wrong. It never sees this touches. Touches never works. So output left index, output right index. I feel like that is correct. Although we do want to start from left index plus 1. And I think we did that somewhere else as well. It should be left index plus 1. And then as it was always doing a diff of 0. Let's just run the cargo test and see whether I've broken 2 pass 1 failed. Okay, so that is still right. Good. So that was wrong, but didn't seem to be affecting things badly. So we get the left region, we get the right region. For the e's, this should now combine them together. So it's iterating over the points in the right region. This if function should return true because the point is touching the left region somewhere. If region contains point add d, so I'm taking this e and saying it's in every direction, so up, left, down, and right. Is that contained in the other region? And it is. It's contained here. So I honestly don't understand why that is not working. So what I'm going to do is construct testcontig.text. Testcontig.text will contain A, E, 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 which would just be a very simple version of what we're doing right now. So let's take this. I don't really care what the solution is. Testcontig. So I should just be able to run it like this. Won't give me that assertion, but I should be able to now check this loop. Okay, let's debug this. So there's a region. We have found. We should be at this point where it combines with this. So if we check, the region should be a vector containing 0, 1. Yeah, that's right, 0 and 1. And the current point we're looking at is 1, 1. Yeah, that's what I expect. That would do it. That would do it. Let's try that again. Cargo test. 1 failed, and it's my test contig. That is silly, but good thing I found it. Okay, let's remove that test contig. Don't need that anymore. Now we can run it on the full puzzle input. In fact, this hasn't changed. So let's remove that. We don't need the print line. And let's implement our actual main. Let puzzle is include string. This will be puzzle test.text. And then we are going to parse it. Let map is can't map from str map. I have no errors being thrown in my code, so I'm just going to unwrap it. And then I'm going to print line part A is map.part A. I'll remove this. I'll cargo run it to check it's okay. It is not okay. Test3.text. Then from str should be from puzzle. From puzzle. Run that. There it goes. We can remove that print line about combining multiple regions. Print line, combining multiple regions. Out we go. Remove that. Remove that. 1930. Yep. Oh my god. All right, let's see how we hold up. Input.text. Paste it in, and where's our main function? Main function is here. Puzzle input.text. Let's run it. And we are taking a long time to do it. Okay. I might want to start printing out the separate stages just to see how far it gets. I'm pretty sure it's just the combining and this for loop that checks whether it actually does touch other regions. I think there's a very rare case where one point allows 3 regions to combine together. Which would probably be caught anyway by another point being added to a region but not combining any regions. So I could feasibly remove this, but it should only cause it to be slower if there are more checks to do. Anyway, I'm going to stop here for today. Made some great progress. We finished day 11 after doing some extra research. We completely passed day 12 and got the test cases working, but it's running very slowly against the real solution. So there's probably something here that I can do to make it more optimal, which I'll investigate tomorrow. So tomorrow I'll continue day 12 and hopefully get to day 13, and we'll see how it goes. Thank you for watching, and I'll see you tomorrow.